All right, we're on Chapter 10, Section 1, which is Learning Plan 5-7, and we're dealing with inverse functions. To know whether something can only be an inverse function if it's a one-to-one. We're going to use the horizontal line test to determine whether a function is a one-to-one, and then we're going to find the equation of an inverse of a function and graph those. So, how do you know whether something is a one-to-one? Well, a one-to-one tells us that for each value of x, or in the domain, there's one value of y. Now, let's look here, and if you notice, every x has a match, but if you notice, this 7 matches with 2 in the domain, so it's not a one-to-one. Every value of x must have only one value of y to which it matches. So the inverse of a one-to-one function is written as f to the negative 1. So that's the set of all ordered pairs. Switch the x and the y around. That's what makes something an inverse function. The domain becomes the range, and the range becomes the domain. Remember, f negative 1 of x, f negative 1 of x does not equal 1 over f of x. Okay, so is this a one-to-one? Each value of y has only one value of x, so yes it is, and that one-to-one would be 5, 2, 6, 3, 8, 4, and 7, 8. This is not a one-to-one because the value 3 has two different choices for it when you go in the reverse direction. It is a function because each value of x has only one value of y, but each value of y does not have only one value of x. You do this one. Okay, the first one is a one-to-one, and its inverse would be negative 2, negative 1, 0, 0. Nope, it's not a function. Sorry about that, because you have two negative 2's. The second one is a one-to-one, 0, 0, 1, 1, 2, 4, and 3, 9. Okay, now that you know something is a one-to-one or not, well, let's look at these two. The first one is pretty easy. It is a one-to-one, so it would be negative 17, 12, negative 9, 15, negative 15, and 12, negative 17. Okay, let's look at this one. F of x equals 7x minus 4. Y equals 7x minus 4 is a one-to-one, and interestingly, its inverse would be x equals 7y minus 4. So you can switch those around, and we're going to see how to do that later on. Find the inverses of one-to-one functions. So for this one, y equals x cubed minus 10. We want to solve for x. So y minus 10, y plus 10 equals x cubed. Take the cube root of both sides, y plus 10 equals x. Or f of x, f negative 1 of x equals cube root, x plus 10. Okay. Use the horizontal line test. In other words, we remember the vertical line test helped us decide whether something is a function. The horizontal line test will also. This, notice you do cross it twice, so this is not a one-to-one. Horizontal line test here only crosses once, so yes, it is a one-to-one. It does have an inverse. Okay. This one, Yes. This one, no. How about this one? Yes, it is a one-to-one. So if you do have a function, how do you make it find its inverse? First step is to interchange x and y, solve for y, and then replace y with f negative 1 of x. So let's look at this one. Y equals 3x minus 4. Switch the x and y. X equals 3y minus 4. Get the y all alone. So x plus 4 equals 3y. Y equals x plus 4 over 3. F negative 1 of x equals x plus 4 over 3. That's how you solve these and find their inverses. So the first one, y equals 5x minus 7. Switch the x and y. X equals 5y minus 7. Get the y all alone. X plus 7 equals 5y. Y equals x plus 7 over 5. Replace y with f negative 1 of x. I'm going to switch colors and do b. This is not a function because when you take the square root of both sides, y equals x plus 1 squared, you get plus or minus here, which means that y will have two values. So it is not a one-to-one. The last one is a one-to-one. Y equals x cubed minus 4. Switch x and y. X plus 4 equals y cubed. Take the cube root of both sides. So f of negative 1 of x equals cube root x plus 4. In general, if something is squared, it's not going to be a one-to-one. Now, how do you graph a one-to-one? Well, what's interesting is if you draw a line through here and reflect the points across that line, you will have the graph of that one-to-one. So notice this point is about down here. This point is about over here. Oops, here, excuse me. This point is equidistant across that line, is right here. So our graph is going to be, oops, did we do all the points? This graph goes like this, and that would be how you would graph the inverse function. So you do this one. We got to get our line of symmetry here. It's going to reflect across this line. Okay, so I didn't get that line right. Should be like that. Okay, so this point is right here, right here. Let's see, this is down here. So our function looks like, inverse function